Works. Okay, so if we're talking about changes in A, what we're focusing on is this letter that's right here today. But we got to see what the parent function is first before we do the rest of it. So what I want you to do is look at your calculator, and we're going to go to y equals, and I want you to put in y equals x squared. This is our original function. Before you make any changes, there's a 1 in front of x squared. It's just y equals x squared. What I want to show you is right here, if you'll go over, use your arrow key to the left side, I want you to press enter until it looks like a darker line. We're going to make comparisons, and we need to keep that line in each of our problems that we do. So you want to compare the x squared to everything else. So this needs to be darker. Use your arrow key over to it. Then when we graph, you can see that we have y equals x squared, makes a parabola, opens up, okay? We can look at the table, and we can see all of our points. Notice your y values. We have 0, 0 that's in the middle. This is our vertex. It could be the low point. If it opens down, it could be your high point. But this is going to be our vertex. On either side, we're putting this number in x squared. So we're getting those perfect squares we talked about before, just for x squared. We're getting these on either side. So that's where we come up with this original picture. So look back at your paper, and let's fill this in. The vertex is 0, 0. Let's put 0, 0 in the center of our chart, because we want to know with the parabola what happens on either side of that. We said here that 1 went to 1, 2 squared is 4, same thing for the negatives. And if you don't know what they are, you can get them off your table, okay? You don't have to do them off of that. Our graph looks like this. And it says, what's the effect on the parent function? This is the parent function. So anytime you have a question that shows you a parabola and says, what is the parent function? Y equals x squared, that's it. So this is kind of our starting point. We want to see on these next three what changes occur to our parent function if we change the number in front of x squared to a number bigger than 1, a number smaller than 1, or a negative. And we're going to compare these in the calculator. So let's start with y equals 2x squared. Go back to your calculator. Go to your y equals. Leave x squared where it is. But add 2x squared there. Don't make that line dark. Just leave it. And then graph and tell me what happens.
We did the same thing, so it's more narrow.
Exactly. That's exactly what we want to say. This is the original line. It's more narrow. So if you have a number that's bigger than 1, it shrinks it. Is one way to word it. It gets more narrow. The values get closer to the y-axis. Okay. So when we put it on our words here on our paper, we want to say the vertex is still at 0, 0. If we look at our table, we find out that if we put 1 in, 1 squared is 1 times 2 is 2. So instead of 1, we have 2. 2 squared is 4 times 2 is 8. And it's symmetric, so the same thing happens for the negatives. But this time, it's more narrow. So compared to the parent function, it's more narrow. Okay, try 1/4 x squared. Do the same thing. This time we want 1/4. So what happens when we graph this one?
It gets wider.
It's wider, okay? So a number that's less than 1, it's going to get wider. So when we go back to our graph here, our table, we want to put that in. It still starts at 0, 0. But this time put 1 in, we get 0.25 or 1/4. We put 2 in, 2 squared is 4, times 1/4 is 1. So it takes longer for this one to get big than it did the other. And I know that's probably not matching those points exactly, but they're really small and they're kind of hard to see. So a number that's less than 1 is wider. Okay, let's try negative 3x squared. Graph that one and see what happens. What does it do? Flips upside down. So if there's a negative in front, it's going to go the other direction. And it's more narrow because of the 3. So we have two things here. We have that it still starts at 0, 0. Because the number added or subtracted to the end is going to change that. We don't have that. So it still starts at 0, 0. But we put 1 in here. 1 squared is 1 times 3 is negative 3. Same thing here because it's symmetric. We put 2 in, 2 squared is 4, times 3 is negative 12. Negative 2 is going to give us negative 12 here. So, and you can get that off your graph, okay, if you don't know what they are, you can get them off your graph. So, this function is going to go down this way. So, the 3 makes it more narrow. And the other one, the negative, means it opens down. That's the correct terminology that we want to use, is that it opens down. So, think back to what we had. We had our original function, and if I were to put the original function in each one of these, this one, it was out here. So the 2 made it more narrow. This one, it was in here. So it made it wider. And then on the last one, this is our original function. This is pointed down, and it's going to make it more narrow. So those are your 3 things that happen with that a in front of their x squared.